If you're looking for a service mesh running without any Sidecar proxy, then this episode is for you. Welcome back to the Is It Observable channel. Today's episode is going to be part of the Kubernetes series. In fact, in this series, we covered lots of different episodes with the how to collect logs in Kubernetes cluster, how to configure Fluentbit, what is a service mesh, what is Istio, the power of Kubernetes events, how to measure cloud costs, what is the Kubernetes API, and way more. Today's episode will be focused on an exciting technology that provides service mesh feature without the need of a Sidecar proxy. And I'm referring to Ambient Mesh. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start with an introduction reminding the challenges of using Sidecar proxies. We'll look at Ambient Mesh, so we explain what is Ambient Mesh. We will see how to collect telemetry data from Ambient Mesh. And as usual, we will jump into a tutorial. As explained in the episode related to service mesh, like the one on Istio or the one on Linkerd, service mesh provides many various features to route our traffic, but it also provides other type of use cases like managing a multi-cluster network, creating a traffic split rules, creating a rate limit rules to protect our services, create retry logics, create circuit breaker. It also rotates the certificates within our cluster and also provide extra observability. To manage all those use cases, a service mesh will manage it by having in one side the control plane where we will define the rules, and all those rules will be injected in our application traffic. And then in fact, it's not in the application traffic, it's gonna be injected into the data plane. So the data plane is composed of our application pod plus the Sidecar proxy that will apply the rules that we have defined in our control plane. So at the end, our application pod will have the application container that we have built and an extra container that will be injected by the service mesh, the Sidecar proxy. The Sidecar proxy will apply all the rules that we have defined in the control plane of Istio or Linkerd. In Istio, the Sidecar proxy is Envoy, and in the case of Linkerd, it's the Linkerd proxy. Sidecar containers are great. It provides lots of flexibility to inject new rules, but it has one major disadvantage. It utilizes more resources in our cluster. Yes, of course. From the moment we add our application to the mesh, then it means that all the pods of our application will have an extra container, and that extra container will of course consume more resources in terms of CPU and memory. But it's not the only downside. First, to make the routing of the mesh, it is required, of course, to inject the Sidecar in our pod, like explained. But if we need to upgrade our Sidecar or change the rules, then we need to restart the entire application pod, which is kind of painful.
Oh, you gotta be kidding me.
Sidecar will capture the traffic to be able to apply various rules that we have applied, like the traffic split, the rate limits, and so on. And in few rare cases, if our application is using a not traditional or conformant HTTP implementation, it could even break our applications. So with the help of Sidecar, most of the service mesh apply all the various rules that we may need to use in our cluster. But to be honest, most of the community using service mesh are using basic scenarios. They need a mesh to first encrypt communication between services. Okay, that's great. They add probably extra authentication between services. They also are looking for extra telemetry data on the network level, and also expose services with ingress or egress rule. So the encryption and security part of the mesh are usually relying on layer 4 of the network. The layer 7, for those who's not aware, is the network layer for the application level. So in the case of HTTP, this is where we can have access to the HTTP headers, the HTTP methods, the response, the request body, and so on. The rules that requires the layer 7 is, for example, traffic split, rate limits, circuit breakers, and more. And if you can imagine, if we look at the actual HTTP traffic and sniff the traffic, we can definitely think that it's going to be more expensive at the end to manage that type of traffic. And at the end, we are not optimizing the way we are allocated resources when using Sidecar, because we inject a Sidecar that can do tons of things, but at the end, we only use a small portion of its capabilities. So is there a way to have the similar feature of a service mesh, but without the need of a Sidecar? Well, it seems it's clearly possible, because several projects have been trying to remove the Sidecar proxies using technology like eBPF. That is the case for Cilium. We already had a dedicated episode about it. And in fact, Istio has also started since a year and a half to create a way of delivering the service mesh feature in our cluster, and this experimental solution is named Ambient Mesh. Ambient Mesh is a potential new version of Istio. Ambient Mesh relies first on the Gateway API, so if you want to know more about the Gateway API, check the video about it. The concept of Ambient Mesh is to reduce the footprint of Istio in our cluster by providing the similar feature of Istio, but without the need of any Sidecar. So how can we manage L4 and L7 rules without the usage of Sidecar proxy? Well, Ambient Mesh has a control plane, like most of the service mesh, and a data plane. The new control plane is made of Istio-D. Similar to Istio, it's going to be deployed in Istio system namespace. And to manage a new network flow of ambient, Istio deploys also a daemon set called Istio CNI node that will be used to manage the network routing of each node. The Istio CNI node will be located in the kube system namespace. Ambient Mesh has also completely restructured the data plane of Istio, in fact, by removing the usage of Sidecar proxies. To cover the similar feature, Ambient Mesh utilizes two distinct components. So we have the Z-tunnel daemon set running on each node of the cluster. And then we have a waypoint proxy deployed if needed on specific namespace or globally by using a service account. Z-tunnel is not relying on Envoy anymore. It is a completely new fresh component of Istio to manage all the L4 network rules that we have defined in the control plane. Z-tunnel will manage all the communication between each node using a secure connection between nodes. The control plane of Istio will send the configuration of the Z-tunnel proxy using the traditional XDS protocol used by Envoy. The Istio team has simplified the configuration aspect of Z-tunnel to make it easier for us. So at the end, we're dealing with a lighter configuration file and a lighter proxy. Then the Z-tunnel pod will have MTLS secure connection with each Z-tunnel of each node. So when a service A is calling a service B, the traffic will go through the Z-tunnel running on the same node as the service A, and then the Z-tunnel will send a secure connection to the Z-tunnel deployed in the same node as the service B, for example. And then Z-tunnel send the call to service B. When deploy Z-tunnel, it's already capturing all the traffic of the node, even if our workload is not part of the mesh. It will start routing and managing the traffic if we add the right label to our namespace. So here is an example of the label. So we have to add istio.io data plane -mode equal ambient. From the moment our application is part of the mesh, the traffic will be encrypted and secure between the services. zTunnel will encrypt the traffic, but also apply network filter rules on the layer 4. That could be easily achieved by deploying an authorization policies CRD added by Istio. If your authorization policy CRD is covering only L4 rules, then the zTunnel will be able to handle it without the need of an extra component. For example, if I want to authorize the traffic of all the services having the label product catalog in the namespace hipster shop and from the Istio ingress, then I could create the following authorization policy. If you want to create a layer 7 rules, then Istio will add another component, a waypoint proxy. The waypoint proxy will run either per namespaces or per service account, depending on how you have deployed your waypoint proxy. The waypoint proxy is in fact a traditional envoy that will be deployed when creating a new gateway. The waypoint proxy is in fact a traditional envoy that will be deployed when creating a gateway in the targeted namespace. The waypoint proxy will be used by the zTunnel if we have applied specific rules on the layer 7. Waypoint proxy is technically optimizing how Istio is managing destination rules. Just to remind, in a traditional Sidecar proxy model, each Sidecar proxy may not know the various deployments or services available or the destination that we have in our namespace or in our cluster. That is the reason why the control plane injects to each Sidecar proxy all the rules that we have deployed. So if you're running in a large cluster with many services, then you can hit to performance issue. The logic of a waypoint proxy is clearly different because we only add the rule, the proxy, on the right destination. So to create a waypoint proxy, you will need to rely on the gateway API by creating a gateway object. So here is an example. As you can see, the gateway class is Istio. Then you can update the previous policy by adding your L7 rules. So here is our updated authorization policy that we have created previously. And as you can see here, I can add specific rules related to the HTTP methods, for example. So we can, of course, add traffic split rules using HTTP routes or gRPC routes as well. So if you want to learn more about HTTP routes, check the video about the API gateway. When using Ambient Mesh, the network flow is clearly different from a Sidecar mode. But the great thing is that the configuration is the same. Rely on the same objects to configure traffic split using HTTP routes. Rate limits, we will use envoy filters. Retry logic, we use destination rules, and so on. If you're looking for service mesh examples on Istio, check the following websites that provides lots of examples of all the use cases that I described. Do we get the similar level of observability data when using Ambient Mesh? Well, before answering that question, let's remind what we are able to get when using a traditional Istio with Sidecar. In the episode introducing to Istio, we were using a quite old version of Istio. Now, currently, the version is 1.18 and lots of improvement has been done in that area. So first, Istio provides out-of-the-box network statistics on the control plane and on the data plane, so each envoy. In fact, all the control plane and envoys are naturally creating Prometheus metrics. So at the end, you need the right scrapping config to collect the data from the control plane and from the various envoy. Next, logging. Envoy generates logs, but recently Envoy has introduced an exciting feature. Envoy is producing logs using the Open Telemetry log format. If you remember well, most of the service mesh is saying in their documentation that they are able to produce distributed tracing. Well, not really. A few months back, it was producing, in fact, open tracing traces using the B3 trace context propagation. That was quite painful, specifically if you're using Open Telemetry. The trace context that we usually use is the W3C trace context. So as a consequence all the spans produced by the Envoy and others were never attached to our application trace. So at the end, you have a separate trace with one or two spans in it that were completely separated from our application trace. Now, this is completely over because Istio is producing by default traces using W3C, trace context propagation. This is a great news. To configure all those aspects, we clearly are not going to connect to each envoy. It doesn't make sense. So to simplify the configuration, Istio has introduced a new CRD, the Telemetry CRD, created to configure the data plane with specific observability settings. Or we can use the Istio operator to configure Istio directly when we are installing Istio. The Istio operator has the advantage to configure the control plane with the right telemetry provider and signals to report. So for example, here is an Istio operator that in fact I'm using in the tutorials to configure Istio directly when I'm deploying it. Here I'm enabling tracing using open census. So each envoy will send open census using the trace propagations of W3C context. And I'm defining the collector endpoints of those traces will end up in my open telemetry collector. Then I'm enabling the envoy logs using open telemetry format. And I'm producing metrics by using the Prometheus feature provided by Envoy and on the control plane. You can see that I'm also defining the provider directly in that settings. So for each signals, in the case of Envoy, I use Envoy logs. So it's named Envoy OTL logs, my provider. And then I use OTLP that use Open Telemetry Protocol. Otherwise, you can also do the similar stuff using the Telemetry CRD. So if you define the Telemetry CRD in the Istio system namespace, it will configure the observability providers and features globally to your mesh. But you can also define it to specific namespaces, so specific settings in specific namespace. So if you deploy it in a specific namespace, these settings will be only true in that namespace. So similar to the Istio operator, you can enable metrics, tracing, define the sampling rates that you want to have in your traces, and the log. Here's an example of a telemetry CRD that enables a tracing with a sampling rate of 10%. And also we enable Prometheus metrics, and we also add extra tags or request methods and a request host. For more information about the Telemetry CRD, check the documentation available on the Istio docs. So now that we know what Istio is able to do, let's cover what Ambient Mesh is providing in terms of observability. Well, in fact, it's going to be similar. If you enable discrete traces, then the mesh will also produce traces. But there will be a slightly different approach, because here we go through gateways if you use ingress. So the gateway will produce traces because it's Envoy, but you won't have the similar network details for each spans for each Envoy proxy, because here at the end we have only one Envoy, which is the waypoint proxy. So less spans produced, which is a good news, because at the end it could be very expensive if every Envoy is producing spans. Next is metrics. So XTOD will still produce metrics, but all the new components will also create Prometheus metrics. So Z-tunnel, the gateway, so the waypoint proxy, and last also the new CNI component introduced by Istio will also provide also Prometheus metrics. So at the end, you will have to create the right scrap config to be able to collect those metrics. So I have built one scrap config that I'm using in my OpenTree collector, and I will show it in the tutorial. Next, logging. So Z-tunnel, the gateway, in fact the waypoint proxy and the CNI node are of course producing logs. So it makes sense to collect those logs, but because Z-tunnel will give you lots of details about the networking happening on the node. So you will have to configure your preferred log agent, so FluentBit or the Open Telemetry collector, to collect those logs. Of course, the logs collected will be raw, so you won't be able to do much about it. So you will still need to parse it using Loki, for example, or Dynatrace with BQL, or any other observability solution that has a parsing feature, because at the end, what we're looking at is to extract upstream information and downstream information. And at the end, probably there is some statistics so we can convert it into metrics and utilize it to create dashboards or to plot those information in our preferred observability solutions. So in this tutorial, we will deploy Ambient Mesh, of course, in the cluster, create an ingress rule using the gateway API, and then add our demo application into the mesh. We will also add in our mesh our open telemetry collector sitting in the default namespace. We will create an authorization policy allowing only post requests that will end up in the collector. Last, I will walk through the settings of the collector pipelines to collect traces, metrics, and logs from the ambient. In this tutorial, all the telemetry data will be sent to Dynatrace, which means we will need a couple of things. Of course, the Kubernetes cluster, like usual, the cert manager, which is a requirement for the open telemetry operator. We'll use the hotel demo application as the demo app. We will then need to deploy the API gateway CRDs. Of course, we'll need to deploy Ambient Mesh. And of course, for that, we will need a Dynatrace tenant to be able to send all the observability data into Dynatrace.
Like every tutorials that we deliver at the Observable, there is always a GitHub repo. So here we're looking at the repo related to this episode, which is Ambient Mesh. So similar to other episode, I'm mainly starting clusters in GCP. You're not forced to do that, so you can just spin up whatever cluster you want. Could be a mini cube or whatever, but here is the instructions if you want to use, of course, GKE. Second requirement, like I discussed previously, is the Dynatrace tenant. So you can click on the link here. It will bring you to this page where you can put your email address and you will get a tenant. So this is required if you don't have a Dynatrace tenant. If you do, then this step is obviously not required. Second thing is because we are going to send traces, metrics, and logs to Dynatrace, like all the various tutorials that we did in this channel, we will have to create tokens to send data to Dynatrace. So for those who never did that in Dynatrace, you will have to go on the bottom, on the left menu, there is a access token. So you click on this one, and you would have a button on the top right, generate new token, and you can give whatever name you want. Expiration date if you need it, and then of course what we want is to ingest. So you will type ingest in the select scope, and you will see there are a couple of scope that we need for these tutorials. We're going to ingest traces, yes. We're going to ingest metrics, yes. We're going to ingest logs. Events is not part of the tutorial, so those three is the minimal scopes that will be required. So once you create on the generate token button, Dynatrace will display the token once, so make sure to copy that and save it to this variable called data ingest token. Then we will run the script with those variables. The second variable is the DT tenant URL. If you go back to Dynatrace on the top here, you can see that we have a URL here. Take everything, so HTTPS included, intil.com. So remove the last slash because otherwise you will probably have a negative impact to the script. Then, of course, once you have this, because we're going to rely on Istio, and to deploy Istio Ambient Mesh, we want to use the Istio CLI, so Istio CTL. So just download the latest Istio CLI using this command, and then you will have to add it into your path. So then Istio CTL is available, because very important, because at the end the deployment script will rely on Istio CTL. If you don't have it, it will obviously fail. So make sure to clone this repo, and once you are in the repo, then we can run the scripts. So what do you get once you have deployed everything? So let's bring up the terminal. We can see that we have, in my case, a couple of namespaces related to Google Cloud, but what is important first is the cert manager is here, obviously, because we use the open telemetry operator. So those two namespaces are technical, and we will need it because we will deploy it. Second thing is we deployed Istio, so the control plane components would be in the Istio namespace. And last, we have the default namespace where we would find our open telemetry collector that will send data back to Dynatrace. And last, we have the hotel demo namespace for our demo app. So first of all, let's see a few things. First, if you look at the pods running in the default namespace, you can see that in my case, I have two node. So I have deployed this collector as a daemon set. So I have this collector running in each of those nodes. So that's the first thing important. Second thing, as of now, you can see that we have all the pods of the hotel demo. Each pod has a second container. Why? Because we do a Sidecar collector to do some manual stuff. And that Sidecar collector is sending to the other collector, which is sitting in the default namespace that we presented a few seconds ago. Second thing we did in this deployment file is we already created an HTTP route and a gateway to expose the hotel demo out of the cluster. So it's an ingress rule. So, which means that's why we have the gateway from Istio. So the gateway class for this gateway is obviously Istio, and that's why we have this pod running in this namespace. And if we look at the services, our external IP address that has been created, so this means that our app is running. In fact, if you look at open the browser, you can see that I have the app running, and at the moment it's just purely the gateway API. The app is not part of the mesh yet. It will be there once we label our namespace. Second thing that is important I want to show you is what we get with the Istio namespace. So we can see that we have three pods running. So one Istio D, the control plane, like explained. And then we have the Z tunnel, the new proxy introduced by Ambient Mesh running in each node. The second piece is of Istio, one component that is also deployed, but in kubesystem namespace now. It's the Istio CNI node. So those two you will have, it's a daemon set, so one pod per node deployed in the kubesystem namespace to manage the network CNI of Istio in this cluster. So now let's add the two namespaces part of the mesh. We want to add the hotel demo namespace and the default namespace. Why? Because basically we want to basically secure the communication between the pods in the hotel demo and of course with the collector. So I will copy two commands. So it's going to be labeling the two namespaces. One is the hotel demo and the second one is the default namespace. So once that is done, then what we can do is basically bring the previous Z-tunnel file, and you can see now we have lots of things going on in the Z-tunnel. So suddenly the Z-tunnel is managing the communication between the various pods, and I'm not gonna go and look at the traffic itself, but the traffic from one services to the other is being basically encrypted. So that's basically the idea behind the scene. And what is great, as you can see, is that if we go back to our hotel demo namespace, we did not restart anything, and we did not have any extra container. It's just by labeling by magic, it was part of the mesh. So that's one thing which is great. Let me bring the IDE. Is I want to create a waypoint proxy. And why? Because remember, I got hotel demo sitting in the hotel demo namespace, and this one is sending telemetry data to the default namespace where we have the collector. So first, I want to create a waypoint proxy, so I'm going to deploy like this, so where I'm authorizing H-point connections. And then I'm creating another gateway for this collector for the default namespace. And I'm doing an authorization policy from Istio. I could have done also an HTTP route, but in my case, I'm doing an HTTP authorization, and in this particular case I want to do a L7 rule, because here it says I only accept I'm not precising the service itself. I'm saying whatever comes in the namespace, I authorize any HTTP post, and because it's gRPC that we are sending the traffic of open telemetry, then this will be allowed. If I do a get, for example, this will be basically rejected by ambient by the mesh. To deploy ambient, I use the Istio operator CRD and I applied it with the Istio-CTL. And I defined I'm going to use ambient. This is how ambient has been deployed. And then I have a mesh config. So here you can see that I have a default config, which is for tracing. You can see that I'm setting a sampling rate of 100%. So no sample. I mean, not everything is sent to Dynatrace. Open census agent. I mean, I'm using it because in the documentation I didn't see the telemetry. That's why we use the OpenSensus protocol. But that's why we have this, so which means on the collector I am receiving OpenSensus, and even if it's OpenSensus, it's using W3C trace context, so no problems for us. So default provider is OTLP, and OTLP is described here. You can see, and we have access logging, so envoy logs. You can see that it's defined here, and that's where we define the actual endpoint. So you can see that we also add Prometheus data. So this is basically where I enable everything. If you look at the pods, let's take the Istio system, but it's going to be the same for the other pods, in fact. So I can do a describe here. What we can see here is that you can see that we have some Prometheus annotation. So the port 15020 in this specific pod will basically bring us some Prometheus data. So I'm not going to do for each individual pods, but zTunnel will provide telemetry data. The CNI node will provide telemetry metrics, and each gateways will also provide telemetry metrics. So if I do that port forward just to show you, so now I can simply go to, and in this case you can see it has downloaded a file. So it's, and if I open that file up, here it is, you can see that we have some data that is being generated from this particular pod. So you have information. So the TCP connection, open, and so on. So you can do this for similar to on the other signals, so nothing changed. Now that you see that logs is enabled, metrics is doing, and then we got technically trace enabled. How do I collect that? So everything would be done through the collector. So if you open that file here, we have the collector pipeline. That is running in the default namespace. I'm using the OpenTelemetry collector CRD from the collector operator, the OpenTelemetry operator. I have a couple of environment variables with the Dynatrace URL, the API token to avoid showing it. And then I'm mounting the, because it's on a daemon set, the path to the logs of the container. So very important aspect. So you have to mount that volumes, because without that you won't be able to read any logs. So what do we have? So we have first a receiver, Prometheus receiver to collect metrics. So here I'm using an OpenTelemetry collector job because I want to send the telemetry data of my collector. So this is a static config, nothing special. IstioD, I took the one by default provided in the Istio documentation. So it's going to basically collect the information from IstioD. So that's nothing new. Envoy stats, it's the same as the one provided by the Istio documentation, so nothing's changed. So that will allow me to get the getaway metrics. Then what is important is the Z-tunnel stats, and you can see that this job here we are because Z-tunnel is on the Istio namespace. I'm looking at the pod in the Istio namespace, and then I'm getting the pod labels, and I'm getting the Prometheus scrap, and if it's true, I'm keep that. I'm getting the port, and then I'm getting the pod name namespace to attach it to the metric. So this is how I'm getting the Z-tunnel metrics that is produced by the Z-tunnel pods. Then we have the same thing with the getaway stats. So the path is stats Prometheus, and similar things. I'm looking at hotel demo and default. So I'm precising the list of namespace that I want to look at, and I'm doing the same thing. So I'm looking at the scrap config is true, and that I'm getting the port and the path, and so on to be able to get that. On the CNI, same thing, but with my kube system namespace. So this is how basically I'm creating the scrap config to that. To get the traces, I explained that a few minutes ago. I have enabled the receiver on OpenCensus. That's how I'm receiving the trace produced by any envoy, because it's going to be an envoy producing those traces. Here we have the file log receiver. So we can do a dedicated episode maybe on this one, but here basically I'm saying what the path. So here it's every pods of this cluster or this node, because it's one per node, one collector per node, and then I'm reading. So I am parsing the logs to get some extra information. I am adding some metadata to get the container name, to get the namespace name, the pod name. So this is how you do it. Of course, I'm receiving OTLP. And then as a processor, what I'm doing here, I'm using a Kubernetes attribute processor to, in the case if it's missing, to attach extra metadata from the Kubernetes cluster. So the pod IP, the pod UID, the namespace, and so on and so forth. And last, the other thing that I'm doing here, I have 3 pipelines, some traces, metrics, and logs. So I will have OpenCensus and OTLP for traces, and then I'm just doing OTLP. Same thing here. You can see that I have metrics. I'm doing the same, OTLP and Prometheus, and I'm sending it to OTLP HTTP, which is Dynatrace. So in Dynatrace, you will get several things. So let me open the layer from the new UI where you're getting different things. If you look at the services, so you need to add. You don't have. If you come to the first time to this new UI, you will have to type here services. It's the old services screens, and you will launch the app. So I already launched several applications in my case. I have the services application, the distributed traces application. I mean, Kubernetes, we don't need it. And then we have logs and events, so we can look at diverse things. So let's just start with the services. So if you look at the services, you can see that all the services from the hipster shop is not the hipster shop. Sorry, from the hotel demo is obviously here. And one thing that's been added, you can see it's Istio. So here we have the hotel demo gateway Istio API. Istio API, the hotel demo gateway Istio, so the gateway used for the ingress rule. And you can see, if you look at this particular services, that it's basically the load generator sending, because it's sending to from the ingress rules, and then it's outgoing to the front-end services. So if we look at this specific trace, and we can see that we have egress. We already have some egress and egress rules here. So I can click on one of those, and I will see that the load generator is sending an HTTP requests, and we have an egress span produced by the envoy. of Istio, which is the gateway, and it's sending to the HTTP GET. So this is how we get traces. In the difference with the traditional Istio with Sidecar, we used to have a trace per Sidecar. In this case, I'm used that gateway only for ingress rules, so that's why I'm getting that trace, that span. So you have less traces. It could be a disadvantage, or it could be an advantage because it was quite expensive to enable tracing sometimes in Istio. The second thing that I want to show you is metrics. So I enable a couple of things. So we have the default metrics. If I go to the last page, we can see that we have a process. We have pilot. So this is all the Istio related information. So pilot, virtual services. So I can look at that. We have actually 30 services. With this collector pipeline, we get the control plane data. We have the hotel collector data. As you can see, we have the envoy metrics as well. So we have a couple of different information about the total connections, and you can see I can follow that. And you can see that there is your IO gateway name, so I should be able to split by gateway. If I have, of course, several gateway. In our cases, we have two, but one is receiving more traffic, obviously, due to the fact that it's the incoming traffic from the outside. So a lot of envoy metrics, as you can see here. And let me check. We have the natural metrics related to our demo application. So that's about it. Now let's look at the logs. So logs and events. Let's open this. All right, so what we can do here, I'm interested in several things. Where is the Kubernetes namespace? Namespace name. We can look at, for example, the hotel demo. And I want to specifically look at one specific pod. Where is the pod name? Deployment name? Gateway. So that would be the logs produced by Envoy. You can see API, we can see everything going on. So which means if I parse those lines, I would be able to do that. And in fact, technically I did that quite a while, in fact. I did that with a traditional Envoy. So normal Istio with a Sidecar. Let me add a new one here. So I'm going to say fetch logs, because here it is. I'm going to run the query once to get the logs. So let's filter by, let's say Kubernetes. Kubernetes. And we should have deployment name. Deployment name. And then it's going to be equal to. Okay. So now that I have my logs, with the right filter, I can basically take the parsing content that I have here. Let me add this. So it was a traditional Envoy logs, so because it's supposed to be an Envoy. Let me check if this works. And it seems that I'm supposed to get some request methods, some response code. And let's check if we have that. We have the upstream, the type, response times, response code, request method. So it seems that the at least part of this is working. So now I'm going to use another method to, after parsing that logs, where I want to create a graph, so response time. Now it's here, and I can basically do like a line chart like this. And I'm getting different things here. I'm getting this external IP address. I got the interesting. I can see that the speed Cloudflare is here for some reason. So that's a pure example of what you can do with the logs. Again, if you go back, so that's with the DQL, with the Dynatrace query language. But if you want, you can still use the traditional screen where it's going to help you to create those filters by looking at, let's say, we also collect from the namespace let's remove this. We also collect the information from the Istio the Z tunnel. So if I look at the Z tunnel, I may also be able to do something about that. There's a couple of information, so you can parse that and provide some duration on microseconds. But again, you will have to parse it with DQL like I showed you in a few seconds.
That's it for today's episode related to Ambient Mesh. So I think Ambient Mesh is removing Sidecar proxy from the mesh. I think it's an exciting feature to reduce clearly the footprint of the mesh. It also provides, as expected, all the various features that we expect from a mesh, so traffic split, rate limits, and so on. And it basically rethink completely how the network flow will go through the cluster, utilizing that tunnel on each node. And if required, if we need L7 rules, we will rely on waypoint proxy. So I think it's a great way of doing it. Keep in mind it's still experimental. You can also combine Ambient Mesh with a traditional Sidecar mode, so both is working pretty well. But from an observability point, I think it's great because we're still able to get metrics, we're still able to get the logs that we need. In fact, the logs is even more, there's more details due to the fact that we have the Z tunnel sitting in the node. Last, Istio is still producing traces, which is a great news. But like explained, you will have less spans that we had in the past using Sidecar, because at the end, it's only going to be produced by Envoy, and Envoy, if you remember, is going to be used with a waypoint proxy. So you don't have the trace for each individual services. You will only have when it goes through the Envoy when you apply L7 rules. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. See you.